Okay, this is lesson 3 from unit 3, and we are starting by multiplying out, by foiling, because this is practice for the next lesson, which is actually multiplying polynomials. So let's just practice a little distributing. Should be very fast. Don't forget x times x is still x squared. Sorry. When you distribute a negative, it switches all of the signs. So this was minus plus minus. This should come out to plus minus plus when I just multiply it by a negative. Again, if you just distribute negative 1, sorry, if you just distribute negative 1, you are just switching the signs. Notice that multiplying by negative 1 is the same as dividing. Okay, so the set problems are actually on the next page. I know it's not the next page for you guys, but stupid PDFs. All right. F plus G. I'm going to write down what F is. And what G is. Notice in this particular case, none of the exponents match up, so none of the terms can be combined. You had 5 terms, you still have 5 terms. Be careful with subtraction. Notice the parentheses around the positive term don't make any difference. You can just ignore them. But when you do this, it switches the signs of those 2 terms. So distribute the subtraction. Okay. So do I want to put it in order? Does it say put it in order? What does it say? Nope. So I'm not going to worry about it. Okay. H plus K. Let's see. This time we have a couple of terms that combine. Negative 6 and 4 is negative 2 of the x plus x to the 5th terms. We only have 3x squared. Let's see. Minus 2x plus 1x is minus 1x. And then 13 minus 9 is positive 4. particularly if there's a bunch of terms. I like to write it down with parentheses first and then distribute. Okay, be careful. X to the fourth plus x to the fourth is not x to the eighth. Exponent in it. Oops. Banana plus a banana is 2 bananas. Okay. Notice that this time the x to the fourth's canceled, so we actually got a lower degree polynomial. Let's see, k plus p. 9's cancel. Okay. I find it helpful to write the things in order to concentrate on one exponent at a time. Let's see, x squared is next. And then the x's, there's only that. There are 2 terms that are constants, -1 and -13. Okay. So just as a warning, okay, the problem is on the next page for me. We're going to graph x plus f plus g. And what we're going to do is make a table of values for each, and then plot the points that we've got. Let's see. 2 squared plus 1 would be 5. Oh, we can do that. All right. So f, g, and then we add the y coordinates. Let's see. Okay, I'm just plugging points in For f and g, let's see. We have to plug the same x values in to combine. Negative 2 squared is positive 4. 4 plus 1 is 5. 1 plus 1, 2. 0 plus 1 is 1, 2. 9 and 1 is 10. That's way off the curve, so we don't have to worry about it much, but add the y coordinates, making sure that the x coordinates match. Okay, so negative 4 plus 5, negative 3 plus 2, negative 2 plus 1, negative 1 plus 2, 0 plus 5, and then that's way off the curve, so whatever. Okay, negative 2, 1, negative 1, negative 1, 0, negative 1, 1, 1, 2, 5. Oh, look it. Okay, and then we have a graph of x squared plus x minus 1. A little review of logarithms because they never go away. Base of the log is the base of the exponent. Go across the equal sign, and the log tells you the exponent. Okay, base again. Go across the equal sign. Okay. More Go problems. Problem 20. Let's see. Evaluate the log. What power of 2 gives you 128? That would be 7. What power of 8 gives you 1? 0. Okay. For powers of 10, you can count zeros. Okay, log base A of a to the 6 is 6. Okay. -3 plus log base 2 of x. Okay. So I'm going to do this in 3 steps like I had been doing. I'm going to do 2 to the x. Two to the 0 is 1. 2 squared is 4. 2 cubed is 8. And then we switch the rows, the columns, sorry, to make it log base 2. And then we'll subtract 3. This is, remember, down 3. So we're going to subtract 3. Okay, 1 -3, 2 -2, 4 -1, 8 0, and then 16 1. And the asymptote, if it's not right or left, the asymptote is still at the y-axis. Okay, so we go down and we head down. Okay. This one is supposed to be log base 2 of x minus 3, which is right 3. Now I just made the log base 2 of x, so I'll do that. Okay. 8 and 3 is 11. Okay, so I added 3 to the x, and now I'll plot them. 4 0, 5 1, 7 2, 11 3, 19 4, well, whatever. And then it's right 3, so the asymptote is at x equals 3. Let me draw that in as a dotted line and head towards it. Okay. Looks like that's the end.